Hey everybody, let's simulate an inverting amplifier using Multisim. Okay, so the op amp, they're right here under the analog components, and go for the 5-terminal op amp because that includes the power supply inputs. Okay, let's zoom in here. Just be careful about which is the non-inverting input and which is the inverting input, because sometimes, you could draw it like this, where the inverting is up on the top, non-inverting is on the bottom, but then also be careful of the power supply inputs. Like this one is the positive power supply input, this one is the negative. Okay, so I'm just gonna leave it how it was by default. All right, so for an inverting amplifier, we want to feed the input. So I'm going to press R to bring up a resistor. Okay, so I'm going to have the input going over here through this resistor, and then the output feeds back to the inverting input. So I'm going to put another resistor. Okay, and then the output here goes through this feedback resistor to the inverting input. For a non-inverting amplifier, it would be your input signal will go here instead, but then the feedback will still go toward the inverting input. We'll talk about that next week. Okay, and then let's see. I'm going to put a ground here somewhere. And then the non-inverting input, I'm just going to tie straight to ground. Okay, and then now for the input signal, I'm going to grab an AC voltage source because we want to test when you have a positive voltage on the input as well as a negative. So we'll just let the AC input kind of do a sinusoidal sweep. Okay, so this here, then the other side ties to ground. Okay, so about this, let's talk about it in a second. Let's add our power supply voltages. So I'm going to add sources, DC source. So let's talk about this. Okay, so let's just say this is 20 volts or something. Okay, so this side is lower, this side is higher. So if I tie the lower side to ground, that's a 0, which means this side is more than this side. How much more? 20 volts. So if I feed that here, that means on this positive power supply input, it's getting plus 20 volts. Okay, let me make a copy of this. And now watch, I'm going to flip this upside down. So now this side is lower than this side, right? So let's say I tie this side to the ground. So now this is 0, and this side is lower by 20 volts. So if this side is 0, this side is negative 20 volts, which I will feed right there to the negative power supply input. Okay. All right. So we're about ready to run this. So let me put a probe here. So that's just going to measure this input signal. So I'm going to run it. I'll see up here for the simulation, transient, right? There's different, this runs basically in real time. Transient will just run one period of the sinusoid. And on the input here, if I click on this, see over here, it's going to go here, meaning 1 volt AC, so it's plus or minus 1 volt. And then here the offset around 0. So it's going to be a sinusoid. The amplitude is 1 with a 0 volt DC offset. So let me just run it. Okay, so you see it's, right, a sinusoid. The amplitude is 1, so it goes plus 1 and then minus 1. And then the period depends on the frequency we're using. But then now, let's get back to our input. Okay. Here. So, right, if I say this is 3, then if I run it again, right, then it's a sinusoid. The amplitude is 3, so it's 3 plus 3 and minus 3. Now back to this. See this voltage offset? Let's say I make this positive 1. That means it's going to be a sinusoid with an amplitude of 3 around the DC offset of 1. So it's going to be, instead of plus 3 minus 3, it'll be plus 4 minus 2. Right, let me run it. See, so plus 4 minus 2. And then let's go back here. There's also the phase. So right now this, if you look at it, that's a sine wave. If I do a phase of 90 degrees, see what's up? It's going to shift the time. Let me just run it. See, so now what was a sine wave is now a cosine. If I go another, let's say 180 degree, then what was originally a sine is going to be a negative sine. See, like this. So that's the phase here. I'll just leave it at 0. Okay, so we're back to the, what do we have? 3. So plus 4 minus 2. Okay, let's get back to our schematic. Okay, now let's measure the output. So the output is right here. So right now I have the resistors the same, so the gain should be 1 if I run it. Okay, let's look at the output. So the green was the input. So for 4 volt input, the output is negative 4. For here in green, for the negative 2 volt input, positive 2 volt output. So the gain is 1, but the signal is inverted. Okay, let's add some gain here. So let's say I make this 2K and 1K. So the gain is going to be 2. So if we run this, right, so green, 4 volt input, negative 8 volt output. Then over here, negative 2 volt input, positive 4 volt output. So now the gain is 2 and it's inverted. And this is only true because our power supply inputs are such that this op amp is running in its linear region. It's not saturating. But let me, on purpose, make the power supply inputs less. Okay, so I'm going to make it, let's see, I'll make this less. And I'll make this less. Okay, so right now the positive supply is 3 volts and the negative is 7. So it's going to saturate if I run this. See? So 4 volt input, we were expecting negative 8 on the output, but it's saturated at negative 7 because of the power supply. And then here, for a negative 2 volt input, we were expecting 4 volts on the output, but it's saturated at 3 because of the power supply. Okay, so that's how you measure the op amp, and then how you demonstrate linear operation and then saturation. And then also don't forget to measure across these resistors here, and then the current. So then you can compute the power for each resistor, for this resistor, and then the one over here, this one over here. Right, so then, because you have to always check to make sure the resistor is not going to exceed its power rating. So if you say, okay, quarter watt resistor, just make sure the power doesn't exceed a quarter watt at its max, right, when it's at its peak here. Okay, so hopefully that's not too bad, and then you have experience working with op amps on Multisim. So let me know if you have questions, and I'll see you in the next video.